Hello students. Today we will explore the importance of water systems and their applications. The phase rule is a fundamental concept in thermodynamics that helps us understand the behaviors of water system in equilibrium. Here, the phase diagram is a graphical representation of phase rule. That is, phase rule is nothing but F is equal to C minus P plus Q. So phase diagram is applied by plotting one degree of freedom against the another one. Here there are two type of phase diagram. One is PT diagram and then another one is TB diagram. So that is pressure and temperature diagram, which is used for one component system, and then temperature and component diagram is used for two component system. So generally phase diagram is used to predict whether an electric alloy or solid solution is formed on cooling a homogeneous liquid containing a different mixture of metals, and also it is useful in understanding the properties of materials and the heterogeneous equilibrium system. By studying the phase rule and water system, engineers can develop a deeper understanding of thermodynamic principles and apply them to design and optimize system in various engineering fields. Let's see the water system. There is one component system. As we all know, water exists in three possible phases, that is solid, liquid, and vapor. There are three forms of equilibrium and is exist in between in the water system. That is solid to liquid, liquid to vapor, and solid to vapor. So in each of these equilibrium involves two phases, and the phase diagram contains curves, areas, and triple points. So this is So these are all the curves, that is OA, OB, and OC curve, and one triple point, that is O, and then areas, that is AOB and AOC and BOC is present in one component system. Let's detailedly discuss about the curves, areas, and triple point in the water system. Curve OA is called the vaporization curve. It represents the equilibrium between water and vapor. So, at any point of the curve, only these equilibrium will exist. That is, water and water vapor equilibrium will exist. So, if you are applying the phase rule, that is F is equal to C minus P plus 2, then the degree of freedom will be 1. That is, component is it is a one component being one component system, so C is 1, and phase, that is water and water vapor, so two phases are exist, so totally 2 plus 2, then F is equal to 1. So this equilibrium will extend up to a critical temperature of 374 degrees Celsius. Beyond the critical temperature, so this equilibrium will disappear and only water vapor will exist. And the next curve is sublimation curve. So in this curve, ice and vapor exist in an equilibrium. So here also the degree of freedom is 1. So this is also a univariate. So here, if you are applying phase rule, then F is equal to C minus P plus 2. Again, we get a value of 1. So this is also univariate. So this equilibrium will extend it up to absolute zero, that is minus 273 degrees Celsius, where no vapor phase can exist, only ice will exist. And the next curve is, that is OC curve. So in this curve, ice and water both are equilibrium with each other. Here, the OC curve will slightly incline towards the pressure axis. So it indicates the melt point of the ice will decreases by increasing the pressure. Okay, so in this curve also the degree of freedom is 1. And the next we are going to discuss about triple point. So triple point is, that is the curve OA, OB, and OC meet at a particular point, which is said to be a triple point. So in this curve, all the phases are equilibrium with each other. That is solid, liquid, and vapor. There is ice, water, and water vapor. All are equilibrium with each other. So if you are applying phase rule for this particular point, then F is equal to component is 1 and phase will be 3 and plus 2, then F is equal to 0. So the temperature of this particular triple point is 0.0075 degrees Celsius and pressure corresponding to triple point is 4.58 millimeter of mercury. So next, apart from these three curves, that is OA, that is vaporization curve, sublimation curve, and then melting point curve, there is one particular curve also exists in the water system, that is metastable curve. So in the metastable curve, supercooled water and water vapor will exist in equilibrium. So supercooled water is nothing but water can also be cooled below 0 degrees Celsius without any formation of ice. So that is said to be a supercooled water, but it is highly unstable. It can easily convert into solid by the slight disturbance. And next we move on to the areas. That is AOC and BOC and AOB. In the AOC, only liquid vapor water exists, and then AOB only water vapor can exist, and then in the area of BOC only ice can exist. If we applying the degree of if we applying the phase rule, then is F is equal to C minus D plus 2. Then component will be 1 and the phase will be 1, then plus 2, then the degree of freedom is 2. So in the area, the degree of freedom is 2, so it is a bivariant. Understanding the phase behavior of water is very essential in various engineering applications such as power generation, water treatment, and HVAC systems. Understanding the phase behavior of water is crucial in designing and operating steam systems such as which is those used in a power plant, and also the phase behavior of water help us to optimize the water treatment process like distillation and crystallization. Thank you. I hope you all are clearly understand about the water system.